Welcome to this first recording, recording 1A, for Unit 2, Chapter 2, Trigonometry on Angles in Standard Position. In this recording, we'll be focusing on the terminology and definitions associated with angles of rotation and angles from 0 to 360 degrees in standard position. Some definitions. A ray is a line with an endpoint that extends infinitely in one direction. For example, we have an endpoint here, and this ray extends down to the right, whereas the endpoint of this ray is right here, and it extends upward to the right. An angle is formed by two rays with a common endpoint. That common endpoint is usually known as the vertex, and the two rays usually extend in different directions to form the angle. One exception to that might be, for example, a 0-degree angle where the two rays would extend in the same direction. An angle of rotation is formed when a ray known as the initial arm is rotated about its endpoint to a new position. For example, here's an initial arm. We rotate it, in this case, counterclockwise, 44 degrees, and that initial arm winds up here at this terminal arm location. Likewise, this initial arm has been rotated counterclockwise 121 degrees, and here is one rotating 274 degrees. In this course, it's important to note that all of our angles of rotation will be measured in the counterclockwise direction. Clockwise direction will be left for Mathematics 3200. The quadrants. The quadrants, just as a reminder from earlier courses, are Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. They are the four regions defined by the X and Y axis. An angle of rotation in standard position. Our earlier examples showed initial arms just about any which way we wanted them. However, to be in standard position, we must have an initial arm on the positive x-axis, that's important, and the vertex located at 0, 0. We begin measuring the angle from the positive x-axis and rotate until we wind up in the quadrant and the location that we want, the terminal arm. Notice the Greek letter theta has been used here. That's often used in trigonometry to refer to angle measures or a particular angle. These angles are not in standard position. In this first example, the vertex is not at 0, 0. The positive, or the initial arm rather, is not on the positive x-axis. In this second example, the vertex is not at 0, 0, so even though the initial arm is on the positive x-axis, because the vertex is not at 0, 0, this angle is not in standard position. And in this third example, the initial arm is not on the positive x-axis. So even though the vertex is at 0, 0, we're still not quite in standard position. Now, let's have a quick look at how we might go about determining the quadrant and approximate position of an angle in standard position. First of all, let's recognize that the x-axis can be represented with an angle of 0 degrees if we haven't rotated this point P anywhere. So here's our initial arm located on the positive x-axis before any rotation has taken place. This line will also be our 360-degree line if we make a full rotation around a circle. Another benchmark angle would be on the y-axis. The positive y-axis can be thought of as our 90-degree line. The negative x-axis can be thought of as our 180-degree line. And the 270-degree line would be on the negative y-axis. And as previously indicated, once we get a full rotation around, we've made it all the way back to 360 degrees, the same location as the 0-degree line. Now, let's take that point P, which is on our initial arm, and rotate it 50 degrees. Well, 50 degrees would be in quadrant number 1, simply because it is an angle between 0 and 90 degrees. Notice this blue arrow here shows the direction of rotation. For this course, usually approximating the position of the initial or rather the terminal arm will be good enough. Recognize that 50 degrees in this case is a little closer to the 90 degree line than it should be to the 0 degree line. Rotating into quadrant 2 to a 130 degree angle, 130 degrees would be a little closer to the 90 line than it is to the 180. And continuing our rotation here into the third quadrant, 230 degrees would be a little closer to 270 than it would be to the 180. And likewise into the fourth quadrant, if we go to 310 degrees, that would be a little closer to the 270 line than it would be to the 360 line. To conclude, an angle theta in standard position has its initial arm on the positive x-axis and its vertex at the origin. All angles of rotation in this course will be measured in the counterclockwise direction starting from the positive x-axis, and you can use benchmark angles of 0, 90, 180, 270, and 360 to help determine the approximate position of the terminal arm and the appropriate quadrant. And here's yet another example for you. In our next clip, we'll be taking a look at reference angles.